problem on balancing of multicylinder inline engine with firing order. Given question: the 6 cylinders of a single acting two-stroke diesel engine are pitched 1 meter apart and the cranks are spaced at 60-degree intervals. The crank length is 300 mm and the ratio of connecting rod length to crank radius is 4.5. The reciprocating mass per line is 1350 kg and the rotating mass is 1000 kg. The speed is 200 rpm. With firing order 153624, draw first primary force polygon and secondary force polygon, second primary couple polygon and secondary couple polygon.
In this video, we are going to understand how to draw primary force polygon and secondary force polygon, as well as primary couple polygon and secondary couple polygon as per the given firing order. Let us first complete the diagram for the position of the planes as per the given data. In this question, there are 6 cylinders and it is two-stroke diesel engine. That means the total number of cylinders are 6. So for this position of planes diagram, we have to show this number of cylinders. So for the cylinder number 1, we will say that C1. So we have to show here with the help of vertical lines. Now if we observe, it is two-stroke diesel engine. So we will first calculate the angle theta, that is the angle in between the cranks. So in this question there are total 6 number of cranks. Now what is the angular difference in between these cranks? So for that we have to first find out what is the angle, total angle turned for power stroke. So in case of two-stroke engine, the power stroke, for power stroke there is 360-degree revolution, and in case of 4-stroke engine the total angle turn is 720-degree. So it is two-stroke diesel engine, so we will take here the total angle turn for power stroke is 360-degree and number of cranks. So number of cranks is equal to number of cylinders, that is 6. So theta, that is the angle interval in between these cranks, is 60-degree. So we can say that if the cylinder 1 is placed, that is the crank angle is at 0-degree, then the cylinder 2 will be at 0 plus 60, that is 60-degree. Then cylinder 3 is 0 plus 60 plus 60, that is 120-degree, and so on. Now pitch is given. So pitch, that means the distance in between the cylinders. So it is 1 meter. So we have to mention here the pitch. So these vertical lines are for 6 cylinders. So we will show here the distance in between each cylinder is 1 meter. Crank length. So this crank length, that is equal to 300 millimeters. So we have to convert it into meter, that is 0.3 meter, and this is nothing but R. So R, that means the angle of rotation. So with the help of this vertical line we have to mention this. So what is the length? So this length is equal for all the cylinders, that is 0.3 meter. Then L by R ratio is given, that is the ratio of length of connecting rod to the crank radius, that is equal to 4.5. So R is given 0.3. So from that we can find out the length of connecting rod L is equal to 1.35 meter. Now reciprocating mass per line, it is also mentioned 1350 kilogram. So these reciprocating masses are placed at each cylinder. and these cylinders are rotating in different planes. So this number of planes we will assign the numbers, that is cylinder 1 is rotating in plane 1, here is 2, 3, 4, 5 and 6. The rotating mass is also given, that is 1000 kilogram. Now speed is given 200 rpm, that is 200 revolution per minute. So from that we can calculate omega, that is 2 pi n by 60, which is equal to 20.9439 radians per second. Now firing order is also mentioned. So firing order 153624, that is when the cylinder 1 is at 0 degree, then after that we have to consider cylinder 5. So I will assign here the numbers, that is suppose I will consider this cylinder number 1 is at 0 degree, then there is cylinder number 5. So crank angle is at 60 degree, then 3, so it is 60 plus 60, that is 120 degree, then 6, that is 120 plus 60, 180 degree, then 2, 240 degree, that is 180 plus 60, 240 degree, and then last one is 4, that is 300 degree. To draw the force polygon as well as couple polygon, we will first prepare one table with reference to this position of planes diagram. First column is for planes. So if we observe this diagram, there are total 6 number of planes. So we will mention here the number 1, 2, 3, 4, 5 and 6. Then second column is for mass in kilogram. So we have to mention here reciprocating mass as well as rotating mass. So here we will add these two masses. So M is constant for all these cylinders, that is 2350 kilogram, and we have to mention this. The next one is the radius of rotation. So this radius of rotation is given, that is the crank radius, and it is 0.3 meter, and it is same for all these planes. So we have to mention this. Now we will calculate the centrifugal force. So centrifugal force, that is mr omega square. But all these cranks are rotating with same angular velocity omega, and we will consider here F is equal to m into r, that is 2350 into 0.3, that is 705. So we have to mention this. Now next column is for the distance from the reference plane. So how to select this reference plane? Now if we observe here the mass as well as radius, then all these terms are known. That is, for all the cylinders, the mass as well as radius is known. So we have to select the reference plane as a middle point. So middle point, that means we will consider here this total distance 5 meter. So we will mention here one point at a 2.5 meter. That is, on left hand side there is a distance of 2.5 meter, and on right hand side there is a distance of 2.5 meter, and we will mention here the reference plane. So this is the reference plane. Now we will select the distance of each plane from this reference plane. So what is the distance of this plane 1? So it is on the left hand side. So for this left hand side we have to use the negative sign, and on the right hand side we have to use the positive sign. So it is the distance, that is here 0.5 plus 2, that is minus 2.5. Then for this 2 it is minus 1.5. Then for this plane 3 it is minus 0.5. For plane 4, now it is on the right hand side, so plus 0.5. Then for 5 it is 1 plus 1.5, and for 6 it is plus 2.5. Now we will calculate couple. So couple, that means this force multiplied by L. So when we calculate this, it is minus 1762.5 minus 1057.5 minus 352.5 plus 352.5 plus 1057.5 and 1762.5. Now we have to draw the primary as well as secondary force polygon as well as couple polygon. So we have to mention here the primary crank position theta and secondary crank position 2 theta. So how to select the primary crank position? So now we have to take the reference for the firing order. So as per the firing order, these angles are mentioned. So for this first cylinder, it is at 0 degree. Then for second cylinder, it is at 240 degree. Then it is 120 degree, 300 degree, 60 degree and 180 degree. Now how to calculate the secondary crank position? So if this primary crank position is theta, then it is 2 theta. So we have to just multiply with 2. That is 2 into 0, 0, 240 into 2, 480. Now we have to subtract 360 degree angle. So it is 120. Then 120 into 2, 240 degree. 300 into 2, 600. But now we have to subtract. One revolution is for 360. So subtract here 360. Then it is 240 degree. Then 60 into 2, 120. 180 into 2, 360. So here also we will consider as a 360 minus 360, that is 0 degree. Now we will draw here the diagram for the primary crank angular position and secondary angular position. So primary angular position for these different cylinders, we will refer this column primary crank position. Now for this one, if angle is 0, so how to draw this? So we will select here one center line and 0 degree, that means one horizontal line. Now for this horizontal line, we will show here one circle. Now for this circle, it is for 1. So I will mention here 1. Then next one is, we will consider 60 degree. So for this 60 degree is for 5. So we will take here angle of 60 degree. We will draw one line and here we will mention the next number is 5. Then 60 plus 60, that is 120. So this 120 degree is for 3. So these angles as per the given firing order. So here 120 degree is for 3. So we have to take 120 degree angle and we will draw one line and mention here number 3. Then next one 240 degree. Now it is for 2. So here we have to take here 240 degree and it is 2. Then next one is 300 degree and it is 4. And last one is 180 degree. So it is for 6. So we have to mention here 180 degree. And it is for 6, so I will mention this. Now if we observe, all these 6 cylinders are getting covered. Now we will draw secondary crank position, and for this we will refer the secondary crank position to theta column. Now if we observe, for plane 1 it is at 0 degree. So for this 0 degree we will draw one horizontal line and we will mention here number 1 for this plane 1. Then the next is plane 2 and it is at 120 degree. So it is 480, but we have to subtract one revolution, that is 360. So we will take here one angle at 120 degree. We will draw one line and here we will mention this plane 2. Then next one is 3. So it is at 240 degree. So we have to take here 240 degree angle, draw one line and mention here the number 3. Then next one is for plane 4, it is 600. But now from this 600 subtract 360, then it is 240. So for this 240, it is the same angle for this plane 3 and 4. So we will mention the same number. Then for 5, it is 120. So it is same for 2 and 5. And then for 6, it is 360. So it is same for 1, that is 360 minus 360 is 0. So we will mention here the number 6. Now we will draw primary force polygon with some suitable scale. We will consider the scale 1 centimeter is equal to 70.5 kilogram meter. So for this 705 we have to take scale 10 centimeter. Now we have to refer this primary crank position theta. So for this plane 1 or cylinder 1 it is at 0 degree. So we will take the reference for this primary crank position. So it is at 0 degree, sign is also positive, that is for magnitude it is positive sign. So we have to draw one horizontal line and direction is towards the right hand side. So we will consider here the reference point as a 0. We will take scale 10 centimeter and here we will give number 1, direction is towards the right hand side. Now after 1 there is number 5. Now this 5 is at 60 degree angle. So we will transfer the same angle with the help of roller, and now we will transfer this 5. Now we have to draw one line with magnitude 10 centimeter. Now here we have to give the next number 5. We will show arrow also. Now next one is 3. Now for this 3, angle is 120 degree, magnitude is same. So for 120 degree we will transfer this angle, and now we will draw one line of 10 centimeter. And here next number we have to give as a 3. Now next number is 6. For 6, angle is 180 degree. Now for this 180 degree, sign is positive. So for 180 degree we have to draw horizontal line and direction is towards the left hand side and give here the number 6. Now next is 2. So for 2, angle is 240 degree. So we will transfer this angle. We will draw one line of 10 centimeter. We will show arrow also. We will give number as a 2. Then next one is 4. For 4, angle is 300 degree. So we will transfer this angle and now we will join this line. And here next number will be 4. So we will take here as a 4 and we will complete. Now if we observe this primary force polygon is closed, that means there is no any unbalanced force. Now we will draw the diagram for the secondary force polygon with scale 1 centimeter is equal to 70.5 kilogram meter. So for this 705 we have to use scale 10 centimeter. Now for the secondary force polygon we will refer secondary crank position. Now if we observe plane 1 is at 0 degree, magnitude is positive, so we will consider one reference point as a point 1. As point 0, and now with positive magnitude we have to draw horizontal line at 0 degree and scale 10 centimeter. So here will be the point 1. We will show arrow also. Now next one is 2. So for this 2, angle is 120 degree. So I will transfer the same angle. Draw one line of 10 centimeter, show arrow, and here will be point 2. Now next point is point 3. So 3 is at 240 degree. So we will transfer this 240 degree angle, and now from this 2 we will draw one line of 10 centimeter. So here the next point will be point 3. Now again next point is point 6. So point 6 is at 360, or we can say 0 degree. So here will be point 6. Next point is 4. So from this 6 again we have to draw here one line for 4, that is the same line, and then after 4 it is, so here 2 and 4, 2 and 4, 2 and 5. So here will be 5. So we have to show here 5, and then 3 and 4. So here this is the secondary force polygon, and that is also closed. That means there is no any unbalanced force. Now we will draw the diagram for primary couple polygon, and for that we will take the reference for this primary crank position theta and the magnitude of couple. If we observe, we will consider the scale 1 centimeter is equal to 117.5 kilogram meter square. Now as per this scale, if we take this 1762.5, then for this we have to take 15 centimeter scale, then 1057.5 we have to take 9 centimeter, and 352.5 we have to take 3 centimeter scale. Now we will move to draw the diagram. So first, for plane 1 it is at 0 degree. So we will take the reference for this primary crank position. So for 0 degree, if we observe, magnitude is negative. So we will take here one reference point as a point 0. Now for this negative magnitude, we have to draw horizontal line but towards the left hand side, and for this 1762.5 15 centimeter we have to take the scale. So for draw one line of 15 centimeter, direction is towards left hand side, and here will be point 1. Now after 1 there is phi. So for this plane phi, angle is 60 degree and here magnitude is positive. So for phi we will take the same angle, that is in the upward direction. So I will transfer this angle, and for this 1057 we have to take 9 centimeter. So I will draw here one line of 9 centimeter. Now give here the next number, that is number 5. Now next one is 3. Now for this 3, negative magnitude angle is 120 degree. Now 352.5 we have to take 3 centimeter. Now draw one line 3 centimeter. Now 120 angle is here, that is in the upward direction. But we have to take here the opposite direction because of this negative sign. So I will transfer this same line. Draw here one line 3 centimeter. Give here the next number as a number 3. Show the arrow also. Now next number is 6. So for 6, magnitude is positive, and for the positive magnitude draw 15 centimeter line. So from this 3 we have to draw one line towards the left hand side and with magnitude 15 centimeter. So we give here the next number as a number 6, show arrow also. Now next one 2. So for this 2 it is 1057. So for this 1057.5 take scale 9 centimeter, but it is in the downward direction, but magnitude is negative, so we have to use the opposite direction. So I will transfer this and we will draw one line of 9 centimeter but in the opposite direction, that is in the upward direction. So here will be the next number as a number 2. Then next one is 4. So for this 4 it is positive and angle is 300 degree. So for this 300 degree with positive magnitude, so direction is downward. So I will transfer this and draw line for 352, that is 3 centimeter. So arrow also. So here will be the next number as a number 4. Now this is the diagram according to this primary crank position and the magnitude. Now if we observe, this primary couple polygon is not getting closed. So we will close this. Now if we measure the distance in between this 4 to O, it is 21 centimeter. So how to calculate the primary unbalanced couple? So for that we have to multiply with omega square. So remember, to calculate primary unbalanced couple, multiply with omega square. So here 21 multiplied with scale 117.5 multiply with omega, we have calculated 21.94 square. So when we calculate, answer is 1.081 into 10 raised to 6 Newton meter. Now we will draw the diagram for the secondary coupled polygon with the same scale as we have used in the primary coupled polygon. So we have to take the scale 1 centimeter is equal to 117.5 kilogram meter square. So here we have to note down one important point, that is the sequence. While drawing the coupled polygon, we have to take as in this direction, that is in the anti-clockwise direction, that is 1, then 5, 3, 6, 2 and 4. So first we will take for plane 1. So plane 1 is at 0 degree, magnitude is negative, and for this negative magnitude we have to take 15 centimeter distance. So first I will take here 0, then this is the reference point, take 15 centimeter line. For negative magnitude, show the direction towards the left hand side, mark here as a point 1. Then after that it is 5. So if we observe 5 is at 120 degree and magnitude is positive. So for this positive magnitude we have to draw. So I will remove this. I will take in this middle at the center. So here is point 1. Now after point 1, if we take 5, then for 5 magnitude is positive 1057, that is 9 centimeter. Angle is 120. So I will transfer this angle. And now draw this 9 centimeter line in the same direction, that is in the upward direction. So here will be next number 5. Then we have to move for 3. So for this 3, if we observe, angle is 240 degree but magnitude is negative. So for this negative magnitude, direction is in this downward direction. So in the opposite direction we will draw one line and scale, that is 3 centimeter. So this point will be point 3. Then next one 6. So for this 6, if we observe, angle is 360 or we can say 0 degree, and here it is positive magnitude. So 1762, that is 15 centimeter towards the right hand side, that is the horizontal line with 15 centimeter. So here mention the point 6. Now 2. So for this 2, again it is angle 120 degree with negative magnitude. So negative magnitude, that means we have to show direction in the opposite direction. So I will transfer this. So it is 1057, that means 9 centimeter. So I will transfer this, and here 9 centimeter line, and direction is in the opposite direction of this because of negative magnitude, and we will show the number, that is number 2. Now next one is 4. So for this 4, it is 240 degree, that is here is 240 degree, and magnitude is positive. So we will transfer the same line and direction is in the downward direction. So from these 2 we will join this. So here remaining distance is 3 centimeter distance. So this diagram is closed and next number will be number 4. Now if we observe, this secondary coupled polygon is closed and there is no any unbalanced secondary couple.